All right, let's talk about rational expressions. Notice this is an R section, which means review, which means it shouldn't be too challenging, and got good news, it's not too challenging. So let's talk about rational expressions to begin with. First of all, the whole concept of a rational expression. Some of you are familiar with rational numbers. Rational numbers are numbers that may be expressed as a fraction of two integers. 7 over negative 3, 1 over negative 15, something like that. Those are rational expressions. If you look at the word rational, you'll see its root is ratio. And a synonym for ratio is, in fact, fraction. So rational expressions, likewise, are fractions. A rational expression is any P over Q, where P and Q are polynomials. So, for instance, here is a rational expression. 3x over. That's a rational expression. There's a polynomial of degree 1. There's a polynomial of degree 2, a binomial, but they're polynomials. Ratios or fractions of polynomials. Well, we're going to be doing with these rational expressions the same thing you do with typical fractions, something like 6/15. Most of you would never turn in 6/15 as a final answer because you realize it simplifies, right? Now, most of you will do it in your head, but here's basically how you simplify a rational expression. You factor the numerator. You factor the denominator. And you look for common factors, and you realize that anything over itself is 1, and what that basically boils down to is common factors cancel. So we get 2/5 in this case. We're going to do exactly the same with our rational expressions. We're going to simplify rational expressions. The first thing we're going to do to simplify a rational expression is factor. Numerator and denominator. So let's factor this numerator and this denominator. Let's see, that's just 3 times x, right? Not a lot of excitement there. Anybody see anything here? Yeah, common factor of x. Factor out the x. Looky there, I have a common factor, top and bottom in the fraction. They cancel, and I get 3 over x minus 6. That's how I simplify a rational expression. Factor the numerator and denominator. Secondly, cancel common factors. All right, let's try another one. You probably are seeing right away that the thing I need to be very familiar with is factoring. To the degree that I can factor the numerator and the denominator. For instance, a binomial on top, first thing I always look for is a common factor, and I got one, 2. Look at your denominator, and you probably notice this is the difference of squares. And that always factors into 2 binomials. Square root of my first term, here and here. Square root of my second term, here and here. Always a plus and a minus. Got a common factor? Yes, I do. X plus 7, X plus 7. Remember, factors are things that are multiplied. That's why I didn't cancel the 3 with the 6. That's not a factor. That's a term, something that's added or subtracted. So I cancel things that are multiplied, factors. There they go. 2 over x minus 7. Same steps. Factor numerator and denominator. Look for common factors to cancel. All right. Another thing you're going to be asked to identify when we talk about rational expressions is something called restricted values. Now, you and I both know that no denominator in any fraction may be 0. Go ahead and try that in your calculator if you've forgotten. Put 7 over 0 into your calculator, and your calculator will say something like error or domain error or divide by 0 error. Basically what it's telling you in all that is get off of Facebook, stop looking, stop playing your video games, pay attention, because there's never a 0 in a denominator of a fraction. This is undefined. So the question is, are there any values of x that would cause my denominator to be 0? It's the whole idea of the domain. Remember that? What are our domain restrictions? The very first one is, will any value of x cause or result in a 0 denominator? So I have to be aware of that. So let's take our same two expressions, this one first, and ask, are there any restricted values? And here's what I do. Number 1, factor your denominator. We've already done that, right? X times x minus 6. Secondly, set each factor equal to 0 and solve. So I have two factors, an x and an x minus 6. Set it equal to 0 and solve. That was pretty easy. That's done. Set x minus 6 equal to 0 and solve. Add 6, add 6. Got it. Final observation, these are your restricted values. So for this rational expression, I set the denominator. Don't worry about the numerator. It's just the denominator I'm concerned with. The numerator can be negative, positive, 0. It can be anything. The denominator can be negative or positive, but it can't be 0. That's the only part I'm worried about. So factor your denominator. Set each factor equal to 0 and solve. Those are my restricted values. Does this thing have restricted values? Yes. And they are 0 and 6. All right, check out this feller. The denominator is x squared minus 49. Step 1, factor. All right, that's x minus 7 and x plus 7. Step 2, set each of these factors equal to 0 and solve. X plus 0 equals 7. So that means x is either 7 or negative 7. Number 3, those are your restricted values. Restricted values, yep, 7, negative 7. Got that idea? All right, let's look at some of your Hawks problems. which almost all of them, you got 11 problems, almost all of them say find the restricted value. So here's my rational expression. I know what to do. It's already factored. Set it equal to 0 and solve. Divide both sides by 27. 0 divided by 27 is 0. Restricted values for x, right there, 0. Find restricted values for this guy right here. Same thing. Set my denominator, don't worry about the numerator, set my denominator equal to 0 and solve. I think I'll add 9. Divide by 8. X is 9/8. This is pretty easy. So set your denominator equal to 0 and solve. All right, find restricted values for this guy. Hey, let me ask you a question. Will there ever be an x that you can pick that would result in a 0 denominator? Will the denominator ever be 0 for any x? Can you pick an x that would make the denominator 0? No. The denominator, whatever you pick for x, is always going to be 13. So there will never be a value x that I can pick that would make my denominator 0. I don't have to worry about restricted values in this case. Restricted values, none. Any x will work. No x will make my denominator 0. So you will not always have a restricted value. All right, let's try this guy. I got a denominator. Let's set it equal to 0. I think I can factor this guy. You see the common factor of x? Let's take it out. So I factored. Set each factor equal to 0. And solve. That one's taken care of. This one's almost there. Divide by 7 and I got it. X is negative 5/7. So I have two restricted values. It can't be 0. It can't be negative 5/7. This is making sense. Set your denominator equal to 0 and solve. Hey, find the restricted values. All right, take my denominator, set it equal to 0, and let's solve this guy. I think this trinomial will factor. It will if I can answer this question. Can I think of two numbers that multiply to give negative 2 and add to give a positive 1? Negative 2 and 1, 2 and negative 1. Do either of those pairs of numbers add to a positive 1? Yeah, that one right there. So this does factor into x plus 2 and x minus 1. Set each factor equal to 0. That's my next step. Minus 2, x is negative 2. Add 1, x is positive 1. Any restricted values? Yep, got two of them. Negative 2, positive 1. All right, this one has two parts. The first one is simply ask me to reduce this particular rational expression. I know what to do. Factor the top and the bottom. The top is already obviously factored. Now factor the bottom. Hey, look there, common factor of x. To reduce something, I factor, look for common factors, and cancel them. So I get 1 over x minus 9. That is the reduced form of this particular fraction. All right, it asked me a second question. Find the restricted values for this guy. Well, that's back to this. Take my denominator, set it equal to 0, and solve. First thing I do is factor if I can, and I can. I've already done it. Next, set each factor equal to 0 and solve. That one worked out nicely. Add 9 to both sides. X is 9. Restricted values, yep, 0 and 9. All right, try this guy. Restricted values again. Take your denominator. Set it equal to 0 and solve. What that means is I got to factor the denominator first. Hey, look there. Difference, 2 squares. You might not know that this is a square, but your calculator will tell you that the square root of 400 is, anyone? Anyone? That's right, 20. Square root of x squared, of course, is x. 1 plus, 1 minus. Square root of this guy, here and here. Square root of this guy, here and here, plus and a minus. Set each factor equal to 0. These are the steps. Factor, set each factor equal to 0. Subtract 20 from both sides. X is negative 20. Add 20 to both sides. X is 20. Restricted values, yep, got 2 of them. All right, how about this guy? Same strategy. Take my denominator, set it equal to 0. Will it factor? Absolutely will. I see x's in both terms. Common factor of x. Set each factor equal to 0. Solve, that was solved. Add 7 to both sides. Divide by 8. X is 7/8. Any restricted values? Yeah. X cannot be that or that because that will make the denominator 0. Getting monotonous? Find the restricted values for this guy. Set your denominator equal to 0 and solve. Here's where I have to ask myself the question. Are there two numbers that multiply to get negative 3, add to get a positive 2? Well, let's list what multiplies to give a negative 3. Negative 3 and 1, 3 and negative 1. This adds to negative 2, but this adds to 2. This is my solution. These are the two numbers that meet the 2 qualifications. So my 2 binomials, x plus 3, x minus 1. So step number 1, set the denominator equal to 0. Step number 2, factor it. Step number 3, set each factor equal to 0 and solve. Add 1 to both sides, x is 1. Subtract 3 from both sides, x is negative 3. Restricted values, yep, they're in there. All right, look at this guy. First of all, reduce this to lowest terms, which means I need to factor. As I look at these two terms, I notice they have a common factor, right, of 3. So look at this guy, it's got a 3. Common factor of 3, yep, you're out of here. Y plus 3 over y. Hey, do I cancel my y's? I do not, That y is not a factor. It's not multiplied. It's added to something. I do not factor, or I do not cancel terms. I cancel things that are multiplied, factors. So this is my lowest term expression. All right, find the restricted values for this guy. You know what to do? Set the denominator equal to 0 and solve. Nothing to factor here, just divide both sides by 3. Y is 0. That's the one restricted value. Sometimes they have 2. Sometimes they have 1. Sometimes they have none, as we saw before. Last one, find restricted values for this guy. Leave an easy one for last. Set my denominator equal to 0. Does it factor? It does not. So I need to solve this for x. Minus 3 minus 3. Divide 7. X is negative 3/7. Do I have any restricted values? I do. Right there. All right. Easy section. Hopefully you'll breeze through this one. On to the next.